Hey guys, welcome back to Chalkboard tutorial. So we're going to be looking at the Doppler effect in this tutorial. And the best way to think of the Doppler effect is, imagine you've ever been in a vehicle or you've been standing whilst an ambulance swooshes past you. Now, the one thing you'd notice is as the ambulance is approaching you, the pitch of the siren tends to be relatively high. And then once it passes you, the pitch quickly registers to a lower note. So the reason this occurs is, let's look at the picture here. So let's presume that the source of sound is the ambulance, obviously. And once the source of sound is moving, the sound waves emitted in the direction of travel, so in this example it's in that way, the direction of travel, the sound waves are compressed. So what happens is, the sound waves you see here are compressed. And what instance follows is, if you look at the frequency or the wavelength gets shorter. And as the wavelength gets shorter, accordingly the frequency or the pitch gets higher. So once that happens, the frequency gets higher. Now, the opposite occurs when the sound waves are emitted against the direction of travel. So if you look here, as you can see, the wavelength gets longer. If you can look at the example here, so the wavelength here gets longer, and as that follows, the frequency tends to be lower as well. So exactly the opposite of what's happening here, the frequency lowers as well. Now, in order to be able to determine this, we have a formula, but we're going to need four quantities in order to be able to work it out. So the first thing we're going to need is the frequency of the source. So the first thing we're going to need is the frequency of the source. The second thing we're going to need is the velocity at which the source is traveling, so the ambulance in this example. And the third thing we're going to need is the speed of the waves, which we're going to denote as c, and that'll help us find the frequency. The equation that we're going to use is, so we have frequency here is equal, we have the frequency of the object divided by 1 minus the velocity of the object divided by the speed of the waves, and that should pretty much give you the answer. So let's do an example here. So let's presume that the frequency of the ambulance is, let's pick a different color. Let's presume that the frequency of the ambulance is 440 hertz. Let's presume the velocity at which it approaches you is 36 meters per second. And let's presume that the speed of sound is 340 meters per second. And we need to find out the frequency at which we perceive the sound. Right, so going off the equation, all you have to do is really plug in the numbers. So we have perceived frequency is 440 hertz divided by 1 minus the velocity of the object, which is 36 meters per second, divided by the speed of sound, which is 340 meters per second. And that should give us the answer of 492 hertz. So 492 hertz will be the frequency at which we perceive the sound.